Okay, today we're going to go over the Chinese remainder theorem. Now, what is the Chinese remainder theorem? The Chinese remainder theorem is commonly known as CRT. Now, what the theorem says is that if you have a bunch of mods, let's say x equals to a1 mod m1 all the way to x equals to an mod nn. You can combine all those mods and say one fact that x equals to something mod m1 times m2 times ... all the way to mn. Now, what is that something? The theorem says that, let's say capital M is the product of all mods. And let's say that bi is equal to m divided by mi. So basically, everything except for the mod I multiplied together. And let's say another. Let's name another variable called bi inverse, which is basically going to be bi. So bi inverse is congruent to. Is not congruent to. It's equal to bi inverse mod m1 mi. Okay, with these three variables, we can represent the question mark and the blank, right? So how do we represent it? Well, what the blank is basically a1 times b1 times b1 inverse plus a2 times b2 times b2 inverse plus all the way on until an plus bn plus bn inverse. Now, how do we prove this? How do we prove that all these modulos can combine to form just one modulo, saying that x is congruent to this mod capital M? Well, one way to prove it is to say, to build that huge number. Now, let me write all the mods again. This time, let's make it simpler. Let's start from a smaller case. Let's say there are three mods. X equals to a1 mod m1. X equals to a2 mod m2. X equals to a3 mod m3. Now, what do we do? Well, the result is going to be mod m1, m2, m3. So, and it has to be a1 mod m1. So let's just start with a1. It also has to be a2 mod m2. So let's add a2 and similarly a3. Now, obviously, this won't work because this is not a1 mod m1, because these two terms are not 0 mod m1. Now, how do we make them 0 mod m1? Well, easy. We multiply them both by m1. So we multiply this one by m1 and multiply this one by m1. Now, that won't solve the problem because there's a similar problem for a2. So we do the same for a2. And A3 as well. So we end up with A1 times M2 M3 plus A2 times M1 M3 plus A3 times M1 M2. Now here's the problem. These are 0 mod M1 now. But this is not A1 mod M1. How do we make it A1 mod M1? Well, this is currently, we see an A1, but there's M2, M3 attached to it. How do we get rid of the M2, M3? Well, we multiply it by the inverse of M2, M3, because the inverse times the original number is congruent to 1 mod, whatever mod you're using. And that would make it A1 mod M1. So let's do it the same for A1, A2, and A3. So we get A1 times M2, M3 times M2, M3 inverse. And this inverse is mod M1 plus A2, M1, M3 times M1, M3 inverse. And this inverse is mod A2 and M2. Sorry if I made a mistake earlier. This is mod M1, mod M2, and the last term, A3 times M1, M2, M1, M2 inverse, not squared, inverse, and this one's mod M3. Now, using the terms we wrote down above, these, we can say A1, that this A1 times B1 times B1 inverse plus A2 times B2 times B2 inverse plus A3 times B3 times B3 inverse. Now, this looks very nice because it is the Chinese remainder theorem. Now, we just have to add more terms to it. And if you can see, if we add more terms to it, it will be the same process here. We can do the same process and get to the same answer. And therefore, we prove the Chinese remainder theorem. Thank you for watching.